Hi, in this screencast we will be using Desmos to graph equations that are linear and nonlinear equations in multiple formats. And so the first thing is you want to go to www.desmos.com, and this is a browser-based graphing software utility. It graphs pretty much everything. It graphs implicitly defined functions. I mean, you name it, it works to graph things. And so let's take a look at, and then once you go to that website, www.desmos.com, click on the launch calculator. You'll get used to doing that, and that should bring you to a screen that's similar to this one that you see here. So here's the graphing window, and this is where we're going to input our equation to be graphed. So the example that we ran in class was x plus 2y equals 4. And one of the beauties of Desmos is that I do not have to have the equation in a specific format in order to graph it. Unlike our graphing calculator, and that is one of the shortcomings of the TI-84, it must be in y equals something format. That's not true in Desmos. I can put the equation in Desmos pretty much any way I like. And so you'll notice that it graphs an equation. We call this equation standard form, and it graphs standard form equations just fine. Let's do one that's kind of obvious. Let's graph the line x plus y has to equal 5 all the time. So what this says is that any ordered pair in this relationship that's going to work has to equal 5 all the time. And so clearly x equals 0, y equals 5. Well, if I plug x equals 0 and y equals 5 in there, I get the ordered pair 0, 5, and that is on the line. And yet another ordered pair that would be on the line is 5, 0. Those are obvious. And those are the y-intercepts and x-intercepts of the graph, for starters, right? But there's a host of others. Clearly this ordered pair right here, let's go to 1. There we go. The ordered pair 1, 4 will satisfy the criteria that 1 plus 4 equals 5. So 1 plus 4 equals 5. And so that's one of the major advantages. And I can graph ordered pairs as another line. I can graph the ordered pair 1, 4, and it puts it right in there for me. And maybe I can graph the ordered, what's another ordered pair that would be where the x and the y coordinates have to sum to 5? Go to the ordered pair 2, 3. And so let's just input the ordered pair 2, 3. Now you'll notice Desmos changes the color. And I think I'd like to keep the color all black for each of my points on this line. And so I'm going to go to Edit List, and then I'm going to just click on the color here, and it'll come up with options. And I'll just change that to black real quick, and then hit Done. And so you can see that several ordered pairs satisfy or meet the criteria that when you sum the x plus the y, it's equal to 5. And you can probably guess not just the whole number ordered pairs, but fractions. For example, what happens when x is 1.5? Well, you'd have to add 3.5 to that. There we go, 1.5, 3.5, because 1.5 plus 3.5 is 5. And so when you're graphing an equation like x plus y equals 5, you're graphing a relationship between the x and the y. And we actually call that relationship linear because it does graph to be a straight line. And it's linear for other reasons that we'll discuss later in the class. But its table that we would get necessarily would also have a certain pattern to it that we will come to know and recognize as being linear. Okay, let's click out of a couple of these. We'll take off those. And let's try another line, lines that students typically have trouble with. So let's try to graph the line x equals -2. And if I just plug in x equals -2, there we are. It's a vertical line. And again, the TI-84 won't graph things that aren't functions. And the line x equals -2 is one of those ones that students typically get mixed up and think it's a horizontal line. But no, it's vertical. And there we are. And we can also let's graph the line y equals, let's graph the line y equals 5. And I think I'll change the color on that. I don't like the color. So let's change the color to purple. So we change the color to purple, and this is the line y equals 5. It's the horizontal line. Those are the ones that are a little harder to graph sometimes, especially with shortcuts. But when you think about it, every ordered pair on here has a y-coordinate of 5. No matter where I am on this line, the y-coordinate is always 5, no matter where I am. And so the criteria or the condition is satisfied that the y has to be equal to 5. The output, or the y-coordinate, is always 5. And that makes that a horizontal line rather than a vertical line. Alright, one other type of line that we can graph, and that's a line that's in point slope form. And a line that looks like this, where we have y minus, let's say y minus 2 equals a slope, let's go 3/2, right arrow before you press the x, or before you put the parentheses actually, and let's go x plus 1. So this will also graph things that are in what we call point slope form of a line. So we have slope intercept form, something like y equals negative 2x plus 6. And we also have standard form, like our graph that we did originally, x plus 2y equals 4. And so you'll see that Desmos can graph lines not only very quickly, but in any format whatsoever. That's one of the major advantages to Desmos. If you use your scroll mouse, you can scroll in, scroll out, and it's also very easy to trace. You just click on the point you want to look at. Sometimes it's hard to be precise, so if I want to look at exactly right here, I have to maybe drag the cursor a little bit. But for the most part, it has that trace command that if I go to negative 0.5, then I'm at 2.25. And I have to just be really careful with my mouse in order to select ordered pairs like that, or in order to trace with Desmos. So that's graphing lines of all forms. Before we're finished, let's graph one more equation. Let's graph the equation in function format. F of x equals negative x squared. Now I'm in the exponent, so I want to get down and put the plus. I don't want to put the plus up here. If I just hit plus right now, it's going to put it in the exponent. So I'm going to hit right arrow, and it just move the cursor down, and then I hit plus 3, and that should be our equation, f of x, or our function f of x equals negative x squared plus 3. Remember, f of x takes the place of y for the most part. And notice because of the square in there, we get a curve rather than a straight line. So that's graphing in this way. And it opens downward. It's a parabola. Its vertex is right here at 0, 3. And we'll be using Desmos to graph intersections of lines and parabolas later. So we might want to know, where do those two things intersect? And that involves the quadratic formula, or involves other types of techniques, solvers and that sort of thing. But you'll see that the Desmos, we were able to click on those points pretty nicely and gives us solutions. And so we can find where a line and a parabola might intersect, for example. Alright, that's the end of this screencast, graphing certain equations in different formats using Desmos.